Welcome, everyone. This is Kevin DeWalt from Prolego. I am here with Justin, and today, man, I've been so looking forward to this because it's just so fun talking to Justin about this stuff. We're going to talk about LLM optimization. The inspiration for this particular discussion is that we meet a lot of teams who have put together a demo or MVP app with a large language model like GPT-4, maybe an open source one. And the conversation goes along the lines like, hey, we built something that sort of works, but it's either slow, it's expensive, or it doesn't really answer the kind of questions our customers have. And this is frequently reported. OpenAI talks a lot about this in some of their workshops. Is that it's really easy to get an 80% solution working with one of these technologies because they're so powerful. But going from that to a production application is hard. So as I talked to Justin and the team about how they do things in certain order, it became clear to me that they had gone through the process that the other high performing teams have done. And that is, it takes like 6 months to a year of just trial and error to figure out how to begin using this technology to solve problems. And so I started putting together a spreadsheet of tips to make LLM optimizations. I shared that with Justin, and he threw it away and made a better spreadsheet. So what I'm going to show you all came from somebody who's actually doing the work and not somebody who's talking about the work. And as you'll see, it's really fun to talk about Justin this stuff. So if you want a copy of the playbook, I've got a little ticker thing running at the bottom there. Just go to prolego.com/playbook and you can download the PDF. And I think being able to refer to all 13 as we have the discussion will make it a lot easier for you, or you might get sick of listening to me and just want to read that instead, whatever you like. So with that in mind, let's jump right into it. Justin, anything you want to add to that while I'm bringing up the screen here?
No, I'll just say when we're talking about optimization, we're really talking about getting better accuracy out of the LLMs. We're not focused on making it run faster or hardware hosting, that sort of optimization, but it's how do you get better answers, better responses, better, for lack of a better word, accuracy out of an LLM.
Excellent. All right. Well, I will challenge that maybe a bit because I think some of these optimizations could result in faster speed, but we'll get that. We'll get there when we talk. But I hear you. It's we're not. You're really talking about the application and the logic layer, not trying to optimize at a lower level infrastructure, like tuning hardware, that kind of stuff.
Yeah, I think no hardware, no API optimization.
Yeah, exactly right. Okay, so this is all about what things a developer can do to make things run faster, right? Yeah. All right, so going ahead of the playbook here, and I've got the playbook on the screen. All right, you break them down into 4 categories: model optimization, prompts, context, and workflows. Tell me at a higher level kind of what these different categories are and kind of why you organized it this way.
Yeah, I think these are the big buckets or the big categories of optimizations that you can look at. So starting with the model optimization, quite simply, that's what model, what LLM are you using? It could be, who trained it, what was it trained on, what's the size, is it quantized, is it fine-tuned, just what's the LLM that you're going to use? And that's usually the first thing you want to consider. Moving on from the model, the next thing is the prompt optimization, which is simply how you and your code interact with the model. What kind of system prompt are you giving it? How are you presenting the task to be done? And moving on from there, these context, and context I think is where it gets really interesting, because now you have your model, and so you have a basic way of communicating with the model through prompts. But by optimizing context, what we mean is pulling in additional information, augmenting your prompts, augmenting the context that the model sees. And especially if you have either proprietary data or private data or just very specialized data, text documents, things like this, you can get a lot of bang for your buck in context optimization. So moving beyond model, prompt, and context, finally, there's workflow optimization. And this is where it can get more fun, more complex, but maybe you're coordinating or orchestrating multiple models, multiple sources of data, giving your model tools, giving it some sort of agency. And so that's kind of the top tier in terms of potential performance, but also complexity.
Excellent. And is it fair to say, I hope you say yes, because actually I wrote it here in the document, but that most teams, like this is kind of the order you go at a high level model, then prompt and context and workflow. Is that like, highest ROI, easiest to harder? Is that it? Okay.
Yeah, absolutely. Start with what model are you going to use? How are you going to talk to it? That's prompts. What extra information you're going to give it? That's context. And then, and only then should you think about more complex workflows.
All right. It's always rewarding to know when I write something in our content that it's actually true. So I guess correctly. All right. So let's just jump into the model optimization. So let me just make sure I get all these on the screen. And I'm going to stop an annoying banner at the bottom there. So I think people will be high current ticker. There we go. All right. So maybe people can ask some questions then. All right. So here are the 4 model optimizations. So before actually, let me just take a step back before getting into this, talking about optimizations. Suppose I'm a team, I've got an MVP running, I built a demo and it's kind of working and I've been tinkering around it. How important is it for me to build an evaluation framework before I start doing any of this?
It's really important. That should really be one of the first tasks, is having some sort of objective evaluation. Because otherwise you could say, well, I'm running this model and it seems to work well. And if I switch to this model, well, what's the difference? Without some sort of objective evaluation, you can maybe get a sense or a feel, what people often say, a vibe from the model. This kind of seems to be working better, but you can't quantify it. And so you don't know if maybe you're just asking some easy questions or questions that happen to work well on this other model. Anyway, all that to say, you need some way to evaluate A versus B on all these optimizations. And so having some base level optimization evaluation suite is really important.
Okay, now we've covered this in other discussions, but it's basically a set of questions or data sources that you curated in advance and you run through your system to see if it's working correctly, and you can evaluate them. Did this particular word appear in the output using Python, or maybe you use LLMs or just human evaluation, depending on what you see. But at least you have some way to measure your results. Otherwise, doing it by feel, it's like, you could just waste a ton of time, which is easy to do, especially when you get the prompts, because it's kind of fun to keep tweaking.
Yeah.
Okay, and then I guess maybe the assumption before you start is that we're assuming that the organization has made this strategic decision about the type of model access they're going to use. Are they going to use third-party API? You're going to use, hey, we're going to use an OpenAI family on Microsoft Azure because that's where our data is and that's what it's approved, and it's going to be 4.0, 3.0, whatever it is. It's going to be one of those. Or I've got a GPU and I can install models up to a certain size. I can't put maybe a 70B model up there, but I could put something smaller, or I'm using a Google. Like there's a strategic decision that kind of grounds what choice of like high level infrastructure you have, because otherwise this becomes, if it's anything anywhere, possibly you could be just jumping from whatever is the latest, new model on the street or new technique.
Yeah.
Okay, choose the right model for the task. You're starting a new team, new project. They want to get going and they want to pick a model. What is your gut instinct when you're beginning the project?
So given the constraints you just mentioned, I mean, if you can use sort of anything, I would start with something on an API, GPT-4, and get the biggest and best model that you can use, especially for a POC, because if the best model, something like GPT-4, can't handle your task, well, then going to a smaller model or to an open source model is probably not going to achieve your task either. So if you can, start with the biggest or the most robust model that you can, something like GPT-4, maybe Mixtral's 8x70B, one of these big models, just to get started and prove out the concept.
Yeah. It's like you could waste an enormous amount of time tinkering around with something small and it could get better in a couple of weeks. And especially when you're just you're kind of at the beginning POC stages, it doesn't, like, the cost isn't going to be that high. I think we spent $65 on API costs last month doing all of our work. So when you're doing a developer team, it's not that much of running high volume, and it's all right to wait a little bit. It's more important that you learn quickly.
Yeah. One other thing I would add here is if Often we think about these kind of conversational chat LLMs, which is a lot of use cases. There are other use cases. So if you have a use case where you need a model to write code or do something very specific, like not just write code, but write SQL, then there are fine-tuned models for that. And so you might want to look at those if you know that you're doing something very specific. Like I'm always writing SQL, or I'm always writing Python. Then GPT-4 might still be a good POC, but you might want to also at least check out to see if there's something specifically for the kind of thing, the kind of task you want to accomplish.
Okay. And then continuing down the list here, choose the model size version. I think this is pretty straightforward. As you get a 3.5 or 4, basically. Anything we need to add there, that might be pretty straightforward based on what we just said.
Yeah, again, I would start with GPT-4, but if it's working really well, it's really easy, especially if you're using the API. You really just have to change the model name, do a quick test with 3.5, and if 3.5 is working well at an early stage, you might want to keep going with that for a little while. So it can be a lot faster. And that's the big trade-off here on choosing the model size version. Is bigger size, you're usually going to get better performance, but at an increased cost of latency. So if you can go from 4 down to 3.5, then it might speed everything up. You might be able to get through experiments faster. But there's always trade-offs. I would only do that if you're seeing pretty good performance from 3.5.
From 4. Or from 3.5.
Like start with 4 and say, yeah, this is doable. Then turn it down to 3.5. If it's still performing well, then maybe stick there because you can get faster results, experiment faster.
Okay. All right, then it's your first project, and you don't have a lot of experience with this, and then you want to jump right into quantization and fine tuning, right? That's day 2.
Not day 2, although it's getting easier, but it's still not a day 2 task. Quantization, especially if you're using an open source model, something like Llama, one of the Mistral models, something like that, and you're running it on your own hardware, on your own GPU, then you might want to look at quantization as a way, like if you can't fit Mixtral 8x70B, well, maybe you get a quantized version, something, and just to, what does quantization mean? Maybe we should say that.
Yeah.
Quantization is a way to take a model and reduce its memory footprint, reduce its size. It's going to have the same number of parameters, but you're reducing the precision on some of the numbers. So it's an approximation. You're going to lose maybe a little bit of accuracy usually, but it's going to be something that fits on your GPU hardware, whereas the larger, fuller model may not. And so you're making the model more efficient, smaller, faster by trading off a little bit of performance. And so this, if you're under a constraint where you want something like a big Mixtral 8x70B model, but it doesn't fit on your GPU, then you can go to like Hugging Face and find pre-built quantized versions of the model. The reason why this may not be your first date or your day 2 task, unless you need it to be, is that you have to install some additional libraries. It can be a little bit more finicky to get up and running. And so unless you really need a quantized version of an open source model and you have real hardware constraints, this is probably not going to be an early optimization.
What I know about quantization is it's smaller, gets pretty close to the same accuracy. Just wait till this one guy called the bloke does it and then download it.
Yeah, you can quantize your own model, but then again, you're introducing more complexity. That's not something that you want to do early on, unless you really need to. But to your point, at this point, I think the bloke on Hugging Face, almost all open source models, he's quantized. He's put them up there for free access.
All right, so this is now you're actually piquing my curiosity here because I realized now I have another question about quantization I didn't know. So are there degrees of quantization? So could we go into a client project and say we're going to take the biggest Mistral model, and the quantized version is just slightly too big for their GPU, and make an even smaller version and test that? Or could we keep distilling it down if we needed to?
Yeah, you can, and there are different layers, and this is certainly not something I'm an expert on because there's different ways to do it. But at the end of the day, it's something like each parameter in a model, we'll say out of the box is 32 bits or 16 bits. Well, let's try to reduce that to 8 bits. You could even go down to 4 bits. I've seen people go all the way down, I think at least once, to 2 bits. And so you're making the size of the parameter smaller and smaller and smaller. And how you do that and maintain performance is where it gets tricky. But yeah, there are tools and techniques to just reduce literally the size of each number, the size of each parameter as it sits in memory.
I got it. So it's based on precision computation of not integers. What's the word I'm looking for in computers?
Floats.
Floats. Yeah, floating number precision. Okay, yeah, okay, right. That I got it. That makes sense. Okay, all right. So then fine tune the model. Now, this is the one where I see fine tuning talked about as if it's like the optimization technique for most teams. And I sometimes it's not clear to me if when people say fine tuning, if they mean fine tuning as we're speaking about it, and as OpenAI describes it, or if they're using that word generally to saying making your system better. So tell me kind of the realities of fine tuning.
Fine tune, as we use the word here, means taking, let's say, an open source model and giving it additional data and running additional training cycles. So you're giving it example input, you're backpropping, you're adjusting the parameters of the model. You're running additional tuning, additional training of one of these pre-trained models. So that's what we mean by fine tuning. And as you see in the when column, in my opinion, this should really be a late stage decision. Based on what we've seen, you can get a lot of performance gains from other optimization techniques that don't require additional training of the model. Additional training means you have to have the hardware or access to the hardware. You have to make training decisions, which is like how much data do you give it? How long do you train it? Do you make sure it's not forgetting other stuff as you're training on new stuff? There's a lot of the complexity just increases quite a bit, in my opinion. I wouldn't do this early. It requires some additional, expertise and evaluation and know-how. If you have your POC, everything's working well, and you want to try to squeeze a little bit more performance or get it running a little bit, I don't know, faster. I don't think even faster is the right word.
Yeah,
it's not something that we see, especially early on. I don't think you're going to see. It'll introduce more complexity than it will solve problems.
I heard, and well, you know what's funny about this, Justin, is that pre-LLMs, like we did this on every project. This is how we worked. It's like Bird families. All we did was fine tune. Like
if you're using Bird, the encoder style transformers for specific tasks like classification, entity abstraction, things like that. Yeah, you have to fine tune. The LLMs are a different machine.
Yeah, and I guess another way I maybe heard this discussed is that some company has taken, I don't know, Meta, OpenAI has taken, more money than God and thrown it out one of these things with all the data in the world and, cranked it through GPUs for 6 months. And now you're trying to come in and nudge that in a different direction. And that's not where you want to go, because it can overfit, introduce errors, like it's easy to screw it up if you don't know what you're doing. And I don't know if this is just something I read, but I've heard people say like, hey, there's no evidence that actually fine tuning makes much of a difference on the majority of problems. Like it's almost like people are realizing the LLMs they generalize so well as a general piece of technology that you're going to do the other optimization techniques we talk about today and never go down this path. It's probably overly reductive, but I've heard that kind of opinion floated around.
Yeah. Well, another way that I look at fine tuning is there's a little bit of stochasticity or randomness when you're fine tuning. You're not quite sure what's going to come out. Especially as we get into the next set of optimizations, by changing the prompts, by changing the context that you give to the LLM, you're also giving yourself more control over the optimization, more control over the output, and better sort of guardrails and guidance for the LLM. It feels a bit more deterministic or guided than fine tuning, which is a bit more kind of open-ended.
Well said. All right. Sounds like a nice key up. Let's go to prompts. So I deliberately avoided, as you did here, using the term prompt engineering, because I find that term is kind of overloaded, and it means so many things to different people. I kind of lose track of what they're talking about. So we broke it down into improving prompts and providing examples. And I can understand what that means. All right. So improving prompts, it's pretty much what it says, right?
Yeah, I mean, this is pretty straightforward, and this should be one of after you choose a model, this should be the next stop, is how are you going to interact with the model? How are you describing the task? If you're using something that accepts a system prompt like GPT-4 3.5, set the system prompt. Describe the format that you want it to return answers, responses in. Just very basic. How do you tell the LLM what you want it to do? And a big caveat here is that there's not one prompt that will work for all models. So if you're using GPT-4 or 3.5 or Mistral 7B or 70B or Mixtral or Llama 2, those models will react to different prompts differently. And so choose your first model, then choose and start iterating on prompts to make sure that you can get the model you're working with to perform well and interact with you and your code the way that you intend.
Yeah, well said. I guess I put this in here. I made one of us said, I don't remember, but also just the fact that user prompts are part of this. So you can, if you have the choice between spending 3 weeks of engineering time optimizing your system level prompts, or you can just give users some examples or a bit of training. A lot of times that's a lot easier. Obviously, that's not going to happen for a mass market consumer application where people have to get up and go. But certainly, if you can just tell people, hey, ask it this kind of thing, don't ask it this, use these words, and that works better. A lot of times, that can make that kind of interaction with users is pretty good. And people are smart. They figure out how to use it real fast.
Yeah. And along those lines, the big companies that are putting out these LLMs, they'll often have that kind of guidelines for users of their LLM. So if you go to OpenAI, if you go to, I think Anthropic has this, I think Mistral also has guidelines for how to structure your prompts. And they'll give you tips there about, how to phrase your task and your questions and things like that. And so if you choose we'll say a Mistral model, go look at their guidance, same OpenAI, see how they recommend you structure your prompts.
So Diver asked a great question here. So switching models to research one to use as a tedious task, as prompts need to be changed as well. I would actually say it's worse than this. Maybe your entire application architecture has to be changed. Because it's like, what information do you provide? How do you provide it? How do you pass things on? How big is the context window? So yeah, this is not something to be undertaken lightly. And there is no magical third-party framework that is going to abstract all this away from from your team.
Yeah, not yet. We're moving towards some standardization in a couple of contexts, but yeah, as Kevin said, switching models is not something you should do lightly because you could just get very different performance with the same prompts.
Excellent question. Oh, that is one that comes up a lot. Okay, so I think that's prompts. There's not a lot more to say to this other than it's just experience, work, and then testing different things. Again, if you have a good evaluation framework and you can rip through this stuff pretty quickly. But I'm even just, when we pull up and talk about some of the client work we're doing, it's amazing how much goes into this. I mean, the conversation we had yesterday, like, what if we do this, put dashes here? I mean, there's like a very low level engineering that happens. It just takes some experience.
Yeah.
But I mean, I guess the best way I'd say it is it's programming, right? If you have the mindset for coding and you know how to break problems down and think logically and test things and evaluate them, you can read discussion groups and see what people in Reddit and X are talking about and what works. Look at documentation. I mean, you can figure it out.
Yeah, you can.
All right. Provide examples.
Yeah, this is often an easy way to optimize a prompt. If you want it to do a certain task, let's see, what's the example here? Tell the model how it should respond. Well, that's a little generic. And so if you have a task, give it examples of the way you want it to look. So for example,
output formatting or something like JSON form. Yeah.
Yeah. So if you want to show it a paragraph of text and extract the names of all the people, well, the LLM will probably do that. And in some cases, it might give you a sentence with names separated by commas. It might give you a list of names. It might give you some other structure of containing the names. And so you could say, give it to me in a JSON format, and here's an example. And then you give it an example paragraph, an example of exactly how you want the output to look. Do that 1, 2, 3 times, and you can get much more reliable output. And in some cases, just a couple of examples. We're working on a project now where we give it 2 pieces of text, and we want it to kind of make an evaluation of these 2 pieces of text. Well, we found that it's useful to give it several examples so that it knows what exactly you're looking for in that evaluation, that comparison of text. So giving it examples is, well, it's just that, giving it several input-output examples so that it can mimic the style of conversation that you want to have with the LLM.
And is there, maybe you don't have the answer to this because I'm just trying to think through. I mean, I think most of us that use ChatGPT are kind of used to doing this because it's just one of the techniques you kind of figure out just because it's not working correctly to get it to do what you want to do it. But like, like when do you like number of examples versus using, you know, RAG or some of the other techniques we're going to talk about in context or workflow? Like, you know, is there any kind of like ballpark, or is it just, you know, it's just testing and seeing how well it works?
I think it's just testing and seeing how.
Okay, all right. Okay, all right, good enough.
We've used, that's a bad answer, but I think it's the right answer. It's an analogy we've used in the past, and it's still coming to mind right now. So I'm going to say it again. Is it's sort of like working with an intern or working with a new person that you've just brought onto your team. So improving your prompts is, okay, how do I effectively communicate with this person? Do they like, you know, written or spoken, or, you know, how do they respond to different conversations? And then if you're showing this person how to do something new, well, you're not just going to tell them what to do, but you're probably going to say, here, for example, do it this way, and show them a couple of examples. And so a lot of it is like bringing a new person onto your team. It's kind of working out the same problems. How do they like to communicate, and showing them examples of the kind of work that they need to do.
Okay. All right. So kind of recapping here, you know, we started off our project. We picked the model we're going to use, maybe the model size or version, although we may come back to that. First thing we're going to do is work our prompts, provide some examples. Now we're going to jump into context, right? All right. So get to everyone's favorite, RAG. So RAG, everyone, including me, talks about LM RAG as a solution. And for most people, that means a like chat with your document, which is the example we all see. And I do the same thing, but really it's an optimization. And if you think about your entire system, retrieving relevant context and injecting that into your prompt at the task specific level is a way to improve performance. What else can we say about RAG that's different than what people are going to hear on a million other websites and posts, Justin?
This is a big category, and it's one of my favorite. And so which direction to go? But I like the way that you said it. On the one hand, this could just be an optimization. Like it could be as simple as, does the LLM need to know what day it is and what day of the week or what time it is, all the way to, if you have very specific data that you need to give or documents, and this is the traditional RAG context. If you have specific documents that you know have the answers to the questions, well, you need to provide that to the LLM. And so, sorry, what was your question?
You know, I think that's it.
I'll give you a quick example, because I'm an F1 fan, and I'm working on this on the side right now of, you know, a model that can answer questions about F1. And the model already knows
Formula One racing for those.
Formula One racing.
Yeah.
And so the model already knows something about Formula One. There's a lot written about on the internet. And so just the internal weights, the model itself knows about Formula One. So for a lot of questions I ask about Formula One to the model, to GPT, it gives me a correct answer. But then the more technical I get, or if I get into regulatory questions, the performance really starts to drop off. And maybe it knows somewhere in its weights, but I can really improve performance by saying, okay, I'm asking a question about Formula One regulations. Why don't I search the regulations and give it some relevant context, pass in some of these potentially useful regulations or definitions about Formula Ones so that the model can give me more precise, more specific answers to questions. And so it's really an optimization, because in this context, because the model already knows generically about Formula One, and it can sort of answer questions about Formula One, but then the more specific, the more technical you get significantly improved accuracy if you provide additional detail in the context in your questions, such as excerpts from regulations or definitions of technical terms.
And I guess the difference what I see from how you've worked versus what I read about this, almost all the examples I read out there say, oh yeah, build a RAG. You got to you take your document, you put it into vector database, and then you ask queries, and some magic goes and matches them and pulls things out. But I see you doing a lot more upfront work to organize the source documents into a way that the LLM can access the information, stripping out indexes, footnotes, retaining hierarchy, like so that so it's a JSON file that has, and it's just if you got a blog of your reviewing restaurants in New York City, and someone types in the name of it, where do I get to a good Italian food on 51st Street? It's pretty easy to do that because it's all it's just generic. But when you're talking about arcane documents and multiple documents and hierarchy and language and like negation, like none of these four apply, and you have to, that information gets passed. And it's almost like if you pick up a document and if the index and the title sections and the way it's organized, that's almost always important information for the reader. Otherwise, people wouldn't put it in there. And so you have to retain that if you want to be able to access the information and answer questions.
Yeah. And that's sort of what we're getting to under challenges and considerations. And so, because I think you can get a lot of potential benefit from including context and bringing a specific side information. But you have to be, I think, smart about how you do that. And now you're seeing a little bit of a schism in people when they talk about this, talk about RAG. On the one hand, people will say, well, just dump all the information. If we're getting up to like 1 million tokens for some of these models and context links, just dump everything. Maybe that'll work, but you also see plenty of situations where if you give it too much context, give the model too much context, the model starts to have difficulty reasoning over really large context, and we'll see kind of dropping information from the middle of the context as a common failure scenario for some of these models. So the way that I've approached this problem is, let's choose instead to be smarter about selecting the context. So do something like a vector search, but make sure you're retaining enough document structure so that it knows the title of the document. If there's nested sections, well, include some of that nesting, include section titles. Doing a little bit more exploratory data analysis up front. And so in other words, understanding the structure of your documents and making sure that you're passing the model specific relevant context that also has the necessary context or metadata to be able to answer the question. So that's maybe a little bit hand wavy, but I think rather than just dump all of your text into the model and hope, fingers crossed, it works well, I think often you can do better by knowing your data, knowing your documents, knowing your text, and then crafting context to present to the model that's very intentional. One of my favorite examples of what you just said, and this is from, let's say a rule book that says you can't do any of the following things, and then there's a list. Well, if you just pass it the list, well, you're not going to know that that's a prohibition instead of an allowance or whatever.
Right. It's like working with insurance companies that get something back from the doctor as part of the underwriting process. So, patient does not have these 9 diseases. Well, you better capture that does not, or you've just, and that negation, that's hard for a lot of models. So dive resident, I'm sorry, go ahead.
No, I was going to say, just to call out the other side of things. So you could just dump, 1,000 pages, but then you're more likely to miss something, not to mention you're increasing cost and latency.
Yep. All right. How is hierarchy retained fit in a RAG? All I know is that it's in a organized JSON file. So Justin, how do you maintain a hierarchy in a RAG? Because I realize I actually don't know.
Well, it doesn't have to be JSON. Actually, when you give it to the model, it's not JSON. Everything gets turned into just a flat text.
Right.
And again, Diver, there's not a one size necessarily fits all for this, but for a couple of projects, the way that we've handled this is you create sort of a tree structure from the document. So you have the title, and then each section is a node, and then each subsection, and you have titles going into those nodes. And so and then you embed all of those nodes. And so if I find like a leaf node, so that's something at the bottom of the tree that has high relevance, I'm not just going to include that, but I'm going to include that leaf node, but I'm also going to include the text that came right before it in the hierarchy and the title of the document. And so again, I'll mention this because we did a video in the past about searching FIA, Formula One regulations. And so what I do there, because they're very structured, very hierarchical, section 13, 13.1, 13.1.a. If 13.1.a is high relevance, I'll include that section, but I'll also include the section 13.1 in the text above it, and even the name of the regulation or the name of the file that it came from. And so it's mapping the original document onto this structure and then thinking about which nodes from that structure do I need to convert to text so that the model has everything that it needs to know. It's a bit of a technical answer, but that's typically the way we approach it, is first map everything into a data structure, something like a tree, and then find the relevant node and then include adjacent nodes in that tree.
Okay, so then where the work comes in is figuring out what you have to include and what doesn't matter, and making sure you don't blow up your prompt with stuff you don't need. Yeah. Okay. All right. So this, yeah, everything is possible. Nothing is easy. All right. So let's blast through some of these. We can probably go through these a little quicker. So provide structured data access. I think we've covered this in the videos, but if you want to give access to a database, a table, then that's a way that's which I guess this is also a form of RAG, right? Because you're augmenting the prompt with some data you're retrieving. But I mean, it's so different than the way most people talk about text. And
yeah,
we've done a bunch of videos on this.
Yeah, when people talk about RAG, they're normally talking about finding text to include. But if you need data from a database, then you need to generate a SQL query, run the SQL query, take the results, and put it back into context. Same idea, different data source.
We've done a number of videos on this, but this is definitely more challenging. Requires agents understanding the structure of the database. But ultimately, I think it is going to be. I think almost every enterprise solution is going to need this, because there are not many high-value business processes that run on pure text. People have things in tables and spreadsheets and databases, and you're going to need techniques to pull these out. All right, integrate multiple information sources, and this is one that I think is not well understood, but I see you using constantly with great results. So I would say if there's one optimization that I would point out here that is probably under discussed, it's probably this one in tools. So so go ahead, Justin. Integrate multiple information sources.
This could be combining sections from a document with output from a SQL database, so kind of combining the previous two rows. Again, just to continue with the theme of the Formula 1 FIA regulation search, what I found to be really useful there is, yes, go through and parse all the regulations and make them available as context via RAG. But then I also had a second set of documents that represented definitions. So in other words, I go through all the documents, and some of these will have appendices that have just definitions. So I take all the definitions. I also went to another place and found a set of common definitions for Formula 1 technical terms, and present that as another source of information for the LLM. So now when I ask a question to the LLM, it does the regulation search, but it also searches through the definitions to look for definitions that may be relevant to my question, or definitions that may be relevant to a regulation that it found. So as a quick example in that context, I was asking a question about driver salaries. Well, it turns out the regulations don't use the word salary. They use cost of consideration, which is a term that's found somewhere in a glossary, either in an appendix or in some other set of definitions. And so it's just an example of, you have your target documents that you want to search over, but if these documents contain, for example, very technical terms, industry terms, terms of art, then having another source of information that can elaborate or expound on that. Just one other quick definition, because we're thinking about this use case as well. If you're looking, let's say, over, again, some sort of very specific, let's say, legal documents, well, rather than just searching the legal documents, you might also want to introduce another set of information or documents that are court interpretations or discussions about the legal documents. So you can say, well, here's this section of a law, and then here's a court interpretation discussing that law, or maybe here's I don't know, a law school case study that's published that you can put along. So looking for different pieces of information so that the LLM can produce a better response.
Yeah,
by giving it more context.
I think almost every company is going to need this for any sort of internal enterprise application, especially when you get into the name of your products, the name of your operations, your workflows, I mean, it's like unless unless you're unless it's Microsoft Word, that's like a ubiquitous thing that GPT-4 is trained on. If you have the name of a product or a service or a solution, there's probably 50 other companies with the same similar sounding name out there, or the name might mean something in common language. And the model's not going to have any idea how to handle this, like an employee would. And so passing these definitions, I've been surprised at how much of a lift this gives us in performance. We're seeing like sometimes double-digit performance results from providing definitions to terms. And I suspect that a lot of people are trying techniques like fine-tuning before using simpler approaches like this that can really give them a quick ROI.
Yeah, and just quickly, because this is straightforward, and we say that in the straightforward, but you also need to really think about the logic of it. So again, if you're using definitions, well, what's the basis of searching those definitions? Is it the user query? Is it the regulations that you found based on the user query? Or is it a combination of things? And usually it's a combination of things. So you also have to consider sort of the logic of how these different pieces of information could fit together.
Okay, so like if it's a chat interface, is it the user or the customer that's going to introduce the definition, or is the definition resident in the source documents that you've built your embeddings on? That's the difference you're saying?
Well, I mean something a little bit different. So, yeah. Okay, so let's
So Justin's so diplomatic. So no, I got it wrong. But now he's gonna say, try to explain it to me. Go ahead.
At the danger of jumping between too many examples, I'm going to use one of the examples that you just mentioned. Let's say that you have a catalog that's describing products, but then you also have on the side a list of SKUs or model numbers, and that map to product names. So I could ask about a product name, and my question has a SKU, and so it needs to go to this side database and look up the SKU based on my question. On the other hand, I could describe a product, and it goes to the catalog and finds, oh, here's the relevant description, and the SKU is over here in the catalog, but now it needs to take that SKU and map it back over to the list of all the SKUs to get the right product name and match it back up. And so in other words, is it doing this sort of secondary information lookup based on my question as a user, or is it looking up something in that definition of that database based on something that it found in the context that was retrieved based on my sort of kind of second order lookup?
I got it. Okay. All right. So
getting into the weeds now, but
yeah. All right.
It can make a big difference.
Yeah. Okay. So yeah, bottom line is you got to know when you're going to encounter the definition to know when to inject it into your application. Okay. You don't just pass all the definitions in the prompt every time. It's not that. It's not okay. Right. All right. So we're going to get through now to the stuff that is really getting into the fun thing. So workflow optimizations. All right. So the first one is implement an agent. What's the deal, Justin? Everybody on the internet's talking about LLM agents. In fact, it's gonna all you got to do is throw a bunch of agents at them and they figure it all out. Isn't that what you mean? Like autonomous agents solve all your problems?
If only. and agents, let's talk about what we mean by agent, but it's really something that can either interact back and forth with you, the user, or with tools, which is the second row here. And so if I ask a question and to a RAG application and it can't come up with the answer right away, it could ask me for additional information. Say, well, I found this, but this is not useful. Do you mean A, B, or C? And I say, oh, I mean B, and then it goes back and does the right thing. Or it could be an LLM that has access to, let's say, a search function, like an internet search function, or it can search documents over here, or it can search definitions, or it can query a database. And so based on the question, the agent can, quote, decide what to do, whether that's run additional semantic search queries or interact with a database or ask you for clarifying questions or feedback. So that's what we mean by agents. And this can be an optimization because a lot of RAG that we were just talking about, sort of one shot. I ask a question, it runs a query, it generates a response. Well, what if it needs to run multiple queries, kind of do multi-hop reasoning, or to get multi-hop reasoning to get an answer to your question? That's where agency and the use of tools can pay off.
Yeah, what I've seen of agents is that tread carefully, like powerful, but cost latency, complexity. Like you add an agent, you haven't doubled your complexity, you might have tripled or quadrupled it. You add 2 agents, you add 3 agents, and then you're looking like one of these open source, auto GPT, whatever. I've seen these ones out there that just spin off stuff all over the place and never accomplish a task. Interesting projects. Not dogging on them, but it's just they're just not ready for prime time.
Yeah, and this is in kind of a late stage optimization, as we laid out earlier. What you just said it, but everything's going to increase complexity, cost, latency, and so if you don't need it, don't use it.
Right. Yep.
If you do need it, then yeah, it's worth developing, but only if you really need it.
So you run as far as you can with prompts, examples, and RAG before you start using agents. Okay. All right. This is one that I don't. The next one is add tools. I see you guys using this all the time, and yet I see almost no. I never see it discussed except for people who are actually trying to do things in a production environment. Anybody who's working on something as a side project, I almost never see this. So tell us what you mean by tools and why is this so powerful?
Tools go hand in hand with an agent. So an agent, on the one hand, it could just talk to you back and forth, quote, talk to you, ask you for clarifying questions, or you're having a conversation. But where the power of an agent really comes in is it can choose different tools to use. So one of our projects here internally, which I think we talked about within the last few weeks, is understanding a code base or asking questions about a
ground
code
crew.
base.
Yeah.
Ground crew. Yeah. And so in that case, we have an agent, and it has access to a suite of tools. And each one of these tools provides a specific functionality to augment what the LLM itself can do. And so you could say, well, I want to ask a question about this function. And so the tool will go off, retrieve that function, or provide a summary of the function. Or I want to know if there's any formatting issues. So the agent then could say, okay, well, if you're asking about formatting, that's really a linting question. And so then it runs a linter as a tool and provides a response through that mechanism. So really you're augmenting this core LLM with additional specialized capabilities. Even if you're doing something like a RAG, something I've done in the past is give the LLM agent the ability to run additional queries, embedding retrievals. So I ask a question, it retrieves context, but then if that doesn't answer the question, the LLM can choose to run another query, and that query is a tool. It can choose to look up a definition of a term that it doesn't understand. That's a tool. And so a tool is access to any sort of functionality that you want to give your LLM access to, so it can just quote decide what to do, kind of anthropomorphizing, but
yeah,
you can reason and choose different tools to answer your question.
And is it fair to say like the benefit of tools is allows you to offload tasks to a function that's more optimized for a task instead of using the LLM for everything?
Yeah, exactly. Like again, if you're asking about code formatting, well, the LLM can probably give you some reasonable responses, but if you give it access to a linter, then the LLM can say, well, run the linter and get a nice, concise set of formatting issues, and then summarize that to you, or just show you the output of the linter.
And I guess one thing I've seen people talking about, like using LLMs as a replacement for traditional machine learning models, and I mean that maybe that's the case a lot of times. But I mean, if you take a linear regression classifier scikit-learn model, trend on your structured data, like, and I hear people say, well, the LLM isn't as good. Well, why do you need to use the L? I mean, use an agent, call them what you have. Don't try to train, don't like try to get the LLM to do everything it's not good at. Use it as the brains, the orchestration, and just call what you've already built. And that allows you to reuse and scale your application much better.
Yeah, 100%. LLMs, they're very impressive, but they are sort of general purpose. And so whenever you get into the situation where you need something very specific that requires a very specific tool, well, don't have the LLM try to do that, because you already have a specialized tool for that.
All right, now we're getting into the really complicated things. Provide out of context variables. So getting back to the scratch pads here. So what do you mean by out of context variables, and what's the use case?
The biggest use case for this that we've come across recently is if you have an LLM that has access to a database through a RAG type of scenario, so it can run queries and get results from a database query. Then you can put that database query, the results from that query rather, into the context. But the danger is if you have a huge database, you could end up with thousands, hundreds of thousands, even millions of database rows that you're trying to put in context, and it won't fit. It'll break your context. And so what we've been able to do in the past is say, okay, run this query and maybe you get 1,000 rows back or 10,000 rows. Rather than put that into the context directly, save that off to the side and then tell the LLM, I ran your query and you have access to the results. What do you want to do with the results? And then maybe it's, summarizing through statistics, or rather than put everything into the context window, give the LLM, and we're now building on each one of these 3 rows. The LLM can use tools to run, let's say, big queries, but then it can use tools to run on the output of those queries. So you're composing things in your code in your program in your computer's memory without having everything show up explicitly in the LLM context.
Okay. Yeah. Clearly a more advanced technique, but I can see for a lot of enterprise applications. I mean, no matter how big the context windows get, your enterprise data stores are going to have more data, right? You're not going to take all your system logs and dump them into an LLM. I don't care how big they get. At some point, you're going to have to run offline processing to figure out what do I selectively give the LLM. And I don't care if they could take 100 million tokens, right? You're going to have databases that are bigger than that.
Yeah, and you just mentioned the use of other ML models as tools. So an example here could be if you're a bank, you have an agent that can run a tool to get all of the users who have had large transactions in the last month. And then you have another tool that can take those results and look for any suspicious activity based on a suspicious activity model that you have built somewhere else. And so it's taking these things and composing them in memory without doing everything in context.
All right, finally, orchestrate multiple agents. Now things get really complicated.
Yeah, well, this is easy to write down, but hard to implement. And what this means, there are different paradigms for this, or different ways you could set this up. But you're using multiple LLMs or multiple sort of interactions with an LLM to do different things. So one example, which is a little bit more straightforward, is if you have a RAG, you retrieve context, you generate an answer. That's one interaction, but then you have another LLM that says, hey, look at this answer and look at the context and tell me if this is a good answer, if this is correct. That's an example that I've seen. So you have like a retriever, summarizer, and an evaluator component is an example.
Yep.
There are many different ways that you can start laying out this pattern, but even in Ground Crew, what we talked about a few weeks ago, some of the tools that our main LLM agent uses will themselves run LLMs to do something. And so you now have sort of a network of LLMs that you can call, and they pass information back and forth. So the possibilities are almost infinite. The complexity can be non-trivial.
Yeah, layers of evaluation framework for each tool, calling each. Yeah, okay, so this could go nuts. Well, Justin, this was great. I mean, let's be clear to everybody. Like, obviously, this kind of development is at the earliest stage here. We're all learning, and we've done our best to try to put together the list of tricks and tools that we've used. So I will just share if you want to download the playbook, there it is. It's free. And this skimming through these 13 might help you identify things that can help you work on your projects. I guess maybe on like pretty like exciting good news for everybody watching this. We hear every day about these breakthroughs in AI and LLMs, and it is stunning what this technology can do. But if you're going to try to build anything real that solves a real problem, you need a team. And for anybody, product managers, developers, data scientists, or people that lead or work with them, this is fantastic news, because you are now have incredibly powerful tools that you can combine in a variety of ways. But the idea that somebody's going to build a high-performing enterprise system by just throwing technology at your existing data and getting it to work is fiction. It's going to take it's going to take engineering work and thinking to be able to build anything real. And for the creators and engineers out there, I really believe the golden era is in front of you. It's incredibly exciting. So, Justin, thank you so much. This was awesome as always. Thank you so much for putting this together. You are uniquely capable of doing this kind of work and breaking things down in a simple way. Thank you so much for doing this, and thanks everybody for watching. I hope this was helpful.